Alright, we can go ahead and get started. Are y'all okay with me recording this? Okay, awesome. So, y'all remember anything about quicksort from class?
Um, unstable, it swaps between terms.
Wait, let me write this. So, yeah, it's unstable. In place. Anything else about quicksort?
It's not order
Hmm?
Is it not order
Yeah. Oh, hello. It's also recursive because it calls upon itself.
That's what makes it for sort.
Oh, it's similar to merge sort in that way. It's recursive and also, yeah, divide and conquer. So, similar to merge sort in that regard. But what makes it different is the use of a pivot. Because merge sort, it just like splits the problem space in half, like regardless of like a pivot. It doesn't like really pick a spot. It just cuts something in half. But with quick sort, you can, you know, pick where you want to split something in half, basically. Or pick out like which number you want to split at half. Alright, does that make sense so far? Awesome. Alright. So I'm gonna go through the steps of it. So step one, you just choose a pivot. So you just pick an element in the array. That's your pivot. And you can do this in like a number of ways, you know. You can always like you can always pick like the first element in your array or the last element. Or just like a random element. I'll just be picking like the last element of the array. It's better if you pick like a random element in your array because like I'll get to that later actually. That's a later thing. But yeah. So for now we pick the last element. All right. And then we do the partition of the array. So elements that are less than the pivot go to the left. Elements that are greater than the pivot go to the right. And once we're done with all of this, we do this because we assume the pivot will be in the right spot. So after that, we use recursion. So split the problem space in half. And we stop at the base case. So base case is when you have a subarray of size 1. So you see that, you stop. Right, and those are like the basic steps for a quick sort. Does that make sense to y'all? Awesome. Okay. I want to move on to the time complexity of it. So, do y'all have to know space complexity as well, or? Okay. Okay. So, the best case for the time complexity, do y'all remember what that is, or?
In log n.
Yep. O of n log n. And this happens when at the pivot you divide into 2 equal halves. The average case is also the same, but the scenario is different, so you divide it into 2 halves. Not necessarily equal, but you know, as you do the sort, it kind of balances itself out, so it's still around O of n log n. And for the worst case, anyone want to take a guess as to what it is?
I think it's squared.
Yeah, n squared. And this is when you use quicksort on an array that's already sorted. Because you're going through all of this and you don't really have like a splitting of the array really, because everything, it's just a mess. But yeah, does that make sense to you with the time complexity? Okay. so we can move on to practice problems now. So let me just give y'all an array. So 11, 1, 3, 4, 17. Okay, so this is our array. I'll work with y'all on this one. So we're picking 5 as our pivot just because, like, it's the last element in the array. So this is our pivot. So we're gonna have 2 indices, I and j. So when we start out, j will be at index 0, and I will be 1 before it. So we look at j. If j is greater than the pivot, make sure I'm saying this right. Yeah. We just increment j and check the next element. Oh my gosh. Okay. So we're looking at 11. 11 is greater than 5, which is the pivot, so we just increment and move on to the next number. Actually, let me use a different color. Look at this. So, oh my goodness. We're taking a look at 1. So we make a comparison. 1 is less than the pivot, so in that case, if j is less than the pivot, we increment I, then we swap I and j. Oh my goodness. So here, I'm incrementing I, and then we swap these, so. So I and J swap. If you were implementing this into code, you would use like a little temporary variable. So you would have like 3 variables, so everything switches properly. But I don't really need to go into that. Okay. And now that we did the swap, we can move forward. So 3 is less than 5. So it falls under the second case, so re-increment I. Then we swap these two. Re-increment J again. Then we make the comparison. So it falls under the second case, so oh goodness. Oh my gosh. Whoa. Re-increment I, and we swap. We check the next element, but since 17 is greater than 5, we don't do anything. We do the same again, but 7 is also greater than 5, so we don't have to do anything again. So now we reached our pivot. Now we're at the end of the array. So when you want to swap the pivot, it goes to I plus 1, like that index. Let me write this index. So we increment I. We swap 5 and 11. And we're done with this iteration of the quicksort. So notice how everything to the left of the pivot is less than 5, and everything to the right is greater than 5. They're not in perfect order, but you know, they're relatively sorted. So then we're gonna call the quicksort again recursively. Like, just pretend like we're doing this in code. So we split this into 2 arrays. The 5 stays where it is because it's already in its correct position. So we just need to focus on the other numbers now. I'll just do one side at a time. I'll start with the left side first. So this is our pivot 4. Like, yeah. This is the pivot. Alright, that's the pivot. So we have our two indices. So we're looking at 1 right now. So 1 is less than 4. So it makes like a little, oh my gosh. Oh my goodness. Here it makes a little pointless swap because like 1 is already like to the left of 4, but yeah. I'm not gonna go through the whole thing, but yeah. But we did do the swap technically. So after that, we increment j. We find that 3 is less than 4. So we also had to perform a useless swap. So we had to increment I and then swap it with j, even though they're both the same number. And this is how you get that O of n squared worst case scenario. Because the array is already sorted in order, so with like each increment you do, you have to keep making these like swaps that don't have to be done. Does that make sense? Okay. So we increment the j one more time. We're at the pivot. So we need to make another little swap, but not really. But the code makes a swap, if that makes sense. So that left array is done. Now we move on to the right array. Okay. Okay. So we have our j at index 0. Our I behind it. And 11 is our pivot. So we compare 17 with 11. That's greater than 11, so we don't do anything to it. And then we increment to the next number, the next element. 7 is less than 11, so we increment I. Then we swap 7 and 17. We increment j. And we're at the pivot, so we swap we increment I, and then we swap 11 and 17. Oh, it's not the pivot anymore. And so we have to do another split. So for the left subarray, there's only like one array because like there's nothing to the right of it to split off, like the right of the pivot, because it's already in its correct position. For the right subarray, we split it into 7 and 17. And we stop right here because this is the base case. So each subarray only has one element, so we stop there. And here, here's our pivot. Technically you would still go through like the whole checking with the two indices, but I think y'all can already tell what it's gonna do, right? So we have to make one more split. So it's just gonna be one because there's nothing to the right of the pivot to split. So this is where we stop. And so here we'll have our sorted array. So it'll be 5. Yeah, this is the array we'll have in the end. So there's not really like any combining of the array, if I'm not mistaken, since it's in place sort. So yeah, correct me if I'm wrong though. It's been a while since I learned this, but yeah. Does this make sense to y'all? Okay. Is this like the method he taught in class? No?
Start on the first. Start on the first, and then you also doing a little bit different.
Like the J is the element, and it goes like, I don't know, it's like.
Yeah.
Oh, you go from the two ends?
Two.
Oh, yeah. Yes, this is the way I was taught when I was learning it, so. Does this make it easier for y'all though? Okay. He's like that. But yeah. I can give y'all another practice problem for y'all to work out on your own first, and then I can work it out on the board. So, right. Um, Alright, this is the array you have to sort, so go through it with your quick sort. You can use like whatever way works best for you, like the way I showed you or the way you learned in class, whatever works best. anyone want to come? Oh. Does anybody want to come up here and do the problem, or do y'all just want me to do it? It's on you? Okay. Alright. I'll just do it with the method I used previously, just for clarity's sake. So, oh goodness. We'll make 18 our pivot. So first we do a comparison. 20 is greater than 18. So we just increment j and look at the next element. "13 is less than 18, so we increment I, and we swap I and j, so 13 swaps with 20. Now that we did the swap, we increment j again. 5 is less than 18, so we increment I, and we make the swap. We increment j again. We see that 3 is less than 18, so we increment I, we make the swap between I and j, so 3 and 20 swap. We increment j again. We see 10 is less than 18. We increment I, and swap I and j. We increment j. 9 is also less than 18. So we increment I and swap 20 and 9. We increment j one more time. We're at the pivot. So, wait, did I swap? My bad. So the pivot's position is I plus 1, and then we swap these. So this is our pivot. And now we have to make, we split alongside the pivot into 2 subarrays. So for the right subarray, we can stop here. We're at the base case. That's not the case for the left subarray. So we make 9 our pivot. So we have our I and j. So 13 is greater than 9, so we just move on to the next element. Five is less than 9, so we increment I. And we swap 5 and 13. We increment j. We see that 3 is less than 9. So we increment I. And we swap. We're done with the swap, so we increment j. 10 is greater than 9, so we move on. We increment j one more time. We're at the pivot, and the pivot goes at the position I plus 1. So we swap. We swap our pivot with 13. So we have to make another split with 5 and 3, and 10 and 13. So these are our two pivots. I'll skip over these since they're like short enough. Y'all already know what to do. You have to make one more split, so we have 5, and then we have 10. And since they're all alone in their array, we stop here. So our final array looks like this. Oops. And when I say like subarray, like it's not like an actual new array is being made because like it's in place. It's just like, I don't know, it's just easier to explain that way if that makes sense. So this is going to be our final array. Alright, is this process clear? Okay. Okay, just one more thing I want to go over. So the quicksort I was using was the Lomuto version. So like with like sorting algorithms and whatnot, there's like different ways to implement them. So Lomuto, that's the one I was going over where, you know, you have your I and J and then you go through the indices. That's the one I was using. I think the one y'all learned in class was, I don't know how to pronounce his name, Hoare's? Hoare's? I don't know. I think this is the one y'all were going over in class because this has the 2 pointers at the end and then you go like from both ends and then you stop once they swap places, so think this is what y'all were doing in class. So I'll put this website on the Moodle page and in the group me, so y'all have like a resource to study from. Yeah, any other questions about this? Alright, are y'all good on Quicksort? Awesome. So, yeah. I think we can call it here.